So today we will discuss regarding the centroid and the center of gravity. So as an the engineer we must know about the centroid. Now suppose we take some plane that is a square, right, and we want to find the whole mass or the weight of the particular square, right. So mostly it is located at one point, right. So this point where the whole area is concentrated is called as centroid, right. So suppose it has the B and D, right. So the area that is equal to B into D, this area is concentrated on this point, right. So this point is known as centroid. So as we are talking about the plane, so it does not have any kind of mass. So when it does not have the mass, so whatever the area of B into D, this area is concentrated on this point, that is known as the centroid. Now we are here to know the centroid as well as the center of gravity. Now what is the center of gravity? Let me take one example. Suppose we have one cube. Suppose we have one cube, right? So this cube having some mass, right. So this mass is concentrated on some inner point, right, some inner point that is known as center of gravity. It means the solid. So in short, this is for the solid, where the centroid is for the plane surface, right. It means the area where we are representing, that is known as centroid, where in the solid we have the mass, so it has some weight, so this weight is concentrated on some point that is known as CG, that is center of gravity. So now friends, we are aware about the centroid and CG, right. So mostly in the engineering problem we are requiring the CG as well as the centroid, right. So as a whole, this phenomena is also utilized in finding out of moment of inertia. So this is the MI. So in that we must know about the MI, and this MI is mostly used in the design, right. So it is very much important to have the knowledge of the center of gravity and centroid. So it clears. So the assignment for you, that is the definition. One, that is the centroid, and second one, that is center of gravity, as well as this is the first question. Second question, that is differentiation or the difference between centroid and CG, right. So here that is center of gravity. Okay, thank you. Then so as we want to know the center of gravity and the centroid, we have some terminology that is required to find out the centroid as well as the center of gravity. So first of all, let me see some terminology regarding this phenomena. The first, that is called as the axis of reference. Axis of reference. Now what is the axis of reference? So the CG or a centroid. See, we have not this required not only for the CG but as well as for the centroid. So the axis of reference, this terminology is not only used for the CG but it is also used for the centroid. So centroid, the CG and the centroid of a body is always calculated with reference to some assumed, see, it is assumed axis. So this assumed axis is known as axis of reference. So as a friend, we take some example of to know the philosophy behind this axis of reference. Let me take a T section. Suppose we have one T section, right? So suppose this width is suppose 200 mm and depth of this flange is suppose 50 mm, and this depth of the web is suppose 100 mm, and the width is suppose 50 mm. So friend, suppose we have a section, this is the cross section of a T beam, and we want to know the center of gravity or the centroid of this particular plane. So in that case, suppose I just have one vertical line which is passing through the vertical face of this flange. Actually friends, this is called as the flange and this is called as the web. So suppose I expand one vertical line passing through the vertical face of this flange as well as one horizontal line at the horizontal axis passing through this bottom of the web, right? So suppose this axis is an x-axis and that is suppose y-axis which intersects over here, right? So this axis x and y, we will find out the center of gravity of this section with reference to this intersection point of x-axis and y-axis. So here this axis x and y is known as axis of reference, right? So in the most of the problem we consider the reference axis, and with respect to this x-axis and the y-axis, with reference to this y-axis, suppose I just draw one vertical line passing exactly at the mid of the flange, right? So it means this is 100 as well as this is 100, right? So this axis, right, which is passing through the mid of the section, and it means this distance is 100. So it means here, see, we have a section, right, this section which is symmetrical. Yes, now we also have another concept that is called as the axis of symmetry. See friends, if you pass out this axis, right, if you cut down this section with reference to this y-axis, right, and you observe the two segment, right, so this is the first segment and this one is the second segment, so both are the mirror, right, it means this T-beam is symmetrical along this axis, right, so that is known as the axis of symmetry. So see, we have another one thumb rule that if you have cross section which is symmetrical with y-axis, then you directly get the x bar, right? So here x bar, that is 100 mm. So that is known as the axis of symmetry.